So the next test I wanted to talk about is this two-sample F-test, which goes by the alternative name of the two-sample variance ratio test. So as we've said before, there's two basic problems in statistics: mean or location, where does the typical observation lie; variance or dispersion, how far spread out is the data. Now, it's not necessarily obvious that when you're given the operational formula that a variance is just calculating a measure of dispersion or spread. But for instance, if you're looking at the two-sample F-test, this is a natural question to ask. So the question you're asking is this: given two independent samples, is one more spread out than the other? In order to two-sample F-test, you need this two-sample F statistic, which is just the ratio of the two best estimates of the sample variance. Okay, and then what you should have is that you then have two sets of degrees of freedom. The first degree of freedom goes with the degrees of freedom associated with the variance estimate in the top half. This is just the number in the sample minus 1. Second degree of freedom is again the number in the sample minus 1. Okay, and then sometimes, depending on which statistical tables you've got, you might need that refers to the sample with the largest variance. So, as an illustrative example then, so suppose you've got the same data that we've seen before, so wage data on 10 advertising professionals, 13 accountants. You want to see this time if there's any differences in the spread of the two samples. Okay, so we did the two-sample t-test earlier in the lecture and we found there was no evidence for a difference in the average salary levels. But now, is there a difference in terms of how far spread out the wages are within each industry? Okay, so this is a simple test which may still have some relevance for the types of data that you might see for dissertations, and again we're just trying to ask here if there is a difference between these two samples in terms of how far spread out they are. And it is again important to recognise in statistics you've got these two different problems. It's not just where typical observation lives, but how far spread out is that data. So there are two questions you can ask then, given two samples like this. Have they got the same underlying mean? And have they got the same underlying variance? And it's the second question that we're asking when we look at this F-test. So some repetition of slides, I'm afraid. So if you're doing this calculation from scratch, you need to calculate the mean and the variance, which would mean that in this case you're operationalizing lots of these standard computations. So in terms of the advertised professionals, so if you're doing this calculation, the first thing to note is that 10 observations in this sample, the mean, what you would take all the observations, add them up and divide by how many there are in the sample. Here the mean is 53.5. In terms of the variance, so you want to minus 1 on the bottom because you want the unbiased sample estimate, and you want this practical calculation formula. The first term here, you just add up the size of all the observations, and then if you plug in the observations numbers one into the formula, you should get the variance for the first sample is 90.778. And again, it's worth taking your time and not making a mistake with this. I've seen students make all sorts of elementary mistakes plugging in formulas, plugging numbers to formulas. Okay, it's not a race. The name of the game is being accurate in this instance. So again, repeating these calculations for the accountants. So I would say here, both in terms of the communication information and as systematic as possible to eliminate errors, to set it out like this. So first of all, state you've got 13 observations in this sample. So what you do is you take all the observations in the sample, add them up. Sample size in this case 13, and I would say set it out like this so that you don't make a mistake, and it should be 1.61. Easier when it comes to hand calculation. Make sure that you actually write down lots of these intermediary steps. Method marks as well if you're marking an exam paper. Now for the variance, again I think there's some in write down the steps that you're undertaking here. First thing is that you're using this bias estimate of the population variance. And this is the sort of practical formula to use. The first term is just the sum of the squared observations, and then if you put numbers into the formula, you should get that the variance comes out at 95.7547. Then you would expect to see mean and variance roughly of the same order of magnitude for both samples. So if you calculate the F statistic, how you do this is that you want the first one to be the largest variance and the second one to be the smallest. So if you're doing this correctly, the F statistic should be bigger than 1. In the tables, so you've got 15 observations in the first sample, and you reorder it like this. This one is 12 degrees of freedom for the first one. Second sample, and you reorder it like this. You've got observations minus 1 gives you 9. Second degree of freedom value will be tables. You need F12 9.05 is 3.07. Value is less than this value, so the p value is bigger than 0.05. So again, it works the same way for all these tests. If the inner design points a different way, you've done it correctly. So the value you've calculated is less than the value from tables, so the p value is bigger than 0.05. Interpretation in this case, there's no evidence p bigger than 0.05 for differences in the variances of each group. The wage levels for the two groups appear to be equally well spread out. Okay, so look here for common sense interpretation to check your findings. So they're similarly professional groups which have a similar level of dispersion. Now, when I've used F tables for hand calculation in the past, sometimes these tables have had missing values, and the point of this has been to say that if it weren't given in the tables in an exam type question, you would have to interpolate. Now, but math students and business students over the years, and actually I think math students are probably the worst for this. The most important thing is you have any hand calculations like this, that you have the numbers that you're able so that somebody marking this can see what you're doing. So the idea would be here you are sitting an exam, you can still get the method marks even if you algebraic mistakes and some numerical mistakes. The way I try to sort of phrase this very earnestly and very positively in lectures in person is to say that I'm more interested in what you can do than what you can't, and if you sort of write everything down, then I can see exactly what you can do, give you more credit. Also make sure you write down if p is less than 0.5 or p is equal to 5. So the idea is that you can sometimes do this doing a calculation if you were doing a written question in the exam running out of time, and also in a question in the exam, write a sentence or two in plain English about interpretation, which could give you. So the F tables I've used before unfortunately contained a lot of gaps. So the idea was that if you were asked for values that weren't included in the tables, you could interpolate, and that would be how you'd solve the answers numerically by hand. Now it's not important this year because there's no written exam. It's possible it might be important in subsequent years, so I was reluctant to really take this material out. Okay, so there's an example here that you wanted the value for F13 tables and F1513. The idea here would be sort of 2/3 of the way, 12 the way towards 15, that you would then use that information to interpolate the formula on the slide. Now, It's not important this year because there is no written exam. Okay, so the nature of the assessment will change. What I would say here though, it's worth sort of remembering that if you're doing any hand calculations for any part of any assessment, systematic as possible, that you're including the intermediary steps, because I've seen lots of students in the past that make silly errors by not including any of the, or not writing down any of their workings. So there's a second example for interpolating F tables here. So suppose that you were asked to find a value for F19.8 and you only had instead F15.8 and F28. Same basic idea, so you know that F15.8 is going to be somewhere lodged in the middle between F15.8 and F8. So since you to the 4/5 20 and only a fifth of the way towards 15, it's natural then that you would interpolate this as 4/5 times the F20 value plus 1/5 times the F15 value, and it should give you, once you do this value of 19.8 being 316. So what you should be looking for here is that this value of 19.8 being 316 between these two values F2 and F8 being 3.15. So there's here because it was in between the days we've not made a mistake. Again, it isn't so relevant on the course this year because there's no written exam, but just get used to, if you have to, any handwritten questions, to making sure you include the workings out and the intermediary steps so that you're not making a mistake. So I wanted to give an example then of how you do this two sample F test in R, and as I go through this, just remember that the alternative name for this test is the variance ratio test. Okay, so in the first step then you've got the same steps as before to read in the data. What you have to do in the second step is calculate the length of each sample, because it's the ratio of the two variances. Hence what I said before, that the alternative name for this two sample F test is the variance ratio test. Now you then have to calculate two-sided p-values a priori if the two variances are different, which sample is bigger. So if is bigger than 1, then the formula F value is instead and the correct p-value. Okay, so the default would be that you do a two-sided test. That's precisely why you have a number 2 there. So variances are not the same. We don't know that if the advertiser's variance is bigger than the accountant's variance, or if the accountant's variance is bigger than the advertiser's variance. Okay, because you don't know this a priori, you need a two-sample test, which would be the default in an. So in use, then what you would do is open this two-sample test work file, same we're using for the t-test example and the f-test example. Then you need to highlight the two variables, advertising and accountants, right click and then select open as group. Now the point here is that in order for this thing to work, you need the thing operating in sort of spreadsheet mode. So if it's not working, as directed there, and then to perform a two sample F test, what you need to do is view the equality and then select equality of variance, click OK. And you get a whole wad of results. All you need is the first row of the table. Same results in the previous slide, or it should give you the same results in the previous slide, but it's slightly differently. So, although eViews produces a wealth of additional information, that's all the information you need. Superficially different to R, where the corresponding p-value could be calculated like that. I am a little bit concerned here because, as far as I can see, the value in R should be the one that's correct, and for whatever reason, you get slightly different answers between eViews and R. And I suspect there are certain instances where there is a discrepancy like this, R is one to trust rather than E views.